So this is the first of its kind, and we have Nagas Cieslak to thank for this. She's in the back there for ISC, and what's happened is that we've had lots and lots of innovation happening on the part of vendors who are first-time exhibitors, and we've, as the conference has grown, we've got more of those folks, and we really wanted to recognize the best of those innovations, and we did that by having submissions and a judging panel. The judges, besides myself, were Rich Bruckner and also Ott Emmen, who is president of Premier Magazine Publications. So without further ado, what we're going to do by way of format is give each person about 10 minutes to go through a very small number of slides, and then I will come back at the end. We will start off with Gaurav Singh.
Thanks, Steve. It's really a pleasure and really an honor for me to be here today. I'd like to start off with, yes, the legal notices, but I'll spare you the details. But effectively what it means is anything that I say shouldn't be used as any forward guidance to the performance of our stock price. But I'm not going to prevent you from doing anything that you want with it. But that's pretty much what it says. Okay, so I'm going to start off with HPC Trends. And being at an HPC conference, I feel like I'm preaching to the choir over here. So I'm not telling you something that you don't already know. But it's useful to put that in context in describing what AppliedMicro is doing in the HPC space. So talking about the trends, with a lot of the new workloads that run in the HPC, there's a strong similarity between the workloads that run in the traditional scale-out big data and the HPC workloads. They tend to be very highly parallel, and they tend to be very I/O and memory bound. So from that perspective, the type of traffic that a HPC server would see would be very similar. The second, which I'm sure you all are aware of, is the emphasis on green computing. We had a panel yesterday where we introduced XGene, which is the world's first 64-bit ARM processor. And one of the panelists made a comment that if we were to extrapolate the current system architectures towards exascale, then that exascale computer would consume the same amount of electricity as the city of San Francisco. Now, if you think about that for a minute, that is a huge amount of electricity for a computer. So any optimization or any energy saving on a per node basis can really go a very long way in terms of making sure that an exascale computer is A, practical, and B, is sustainable. Because as you all know, the cost or the operating cost of these computers far exceed the acquisition cost. And making the energy consumption of these large computers efficient also means that they will be utilized for a longer period of time. So any small energy saving that can be brought on any of the components of this computer are highly desirable. The third trend is really bringing to bear the best of breed rather than an all-in-one or one-size-fits-all. Applications that need a lot of floating point performance could do very well with very specialized silicon and hardware for floating point computation. Similarly, with the interconnect, if you really want to build a large cluster with very low latency fabrics, why not pick the best of the breed in terms of the bandwidth and latency? And there's a very similar parallel to the compute as well. Why not pick the most energy efficient CPU for the task? So quick recap of workloads. You all familiar with the informatics, fraud detection, cybersecurity? It's the classic finding a needle in a haystack type applications. Life sciences, genome sequencing. Smart electrical grids, where the computer tries to balance the need or the dynamic change in the load versus the supply. So a lot of these workloads tend to be very I/O intensive. There is a lot of data that moves in and out of the CPU. So there's a big emphasis on having very efficient I/O, having lots of cheap memory on every node, and having a very good compute module. So that's the trend in terms of the workloads. What really is needed is to have a CPU that balances memory, I/O, and compute. So I'd like to introduce Xgene, which is the world's first 64-bit ARM processor for HPC, which we at AppliedMicro started to design about 5 years ago. We did that concurrently with the development of the architecture specification from ARM, and that's the reason why we were the first to come out with an implementation. I'd like to point out that the CPU itself has been a design at AppliedMicro. We have a long history of designing CPUs. We've done CPUs in the past at AMD, Intel, and Sun. So the same design team designed the CPU. It's a very high performance. It's a 4-issue, 2.4 gigahertz and up. Full reorder capabilities. Very tightly integrated floating point unit with full support for the ARM v8 SIMD unit. So we can do all of the double precision math, multiply accumulates very fast at full speed. The first iteration of Xgene has 8 of these high performance CPUs coupled with an on-chip fabric, which is a terabit per second. And so we see a very linear scaling of performance as you increase the load from 1 CPU to 8. It has 4 DDR3 interfaces, so there's plenty of memory bandwidth. And one of the key things in a lot of these applications where you need a lot of memory is you need to have a lot of cheap memory. So having 4 memory channels allows you to pack in lots of cheap memory rather than putting in very expensive DIMMs. We've also integrated the key interfaces that are required on these computers. First and foremost is we've got 4 10 gig interfaces completely integrated. So there's no need for an external NIC card. 6 PCIe Gen 3 controllers with lots of links. And we've got 6 SATA ports. In addition to that, we've also integrated the physical layer, which is one of the key IPs that AppliedMicro as a company has been working on for quite some time. In fact, we are shipping 100 gig OTN framers, mappers, and PHYs into the telco space. We've been doing that for a while. We are the leaders in that space. So we brought to bear the CPU design capabilities in addition to the I/O mixed signal technologies into one single die. And that's the Xgene CPU. So we are very proud to be here. We're very proud to be working with a lot of the system integrators, and you can see some of those systems that are up and running in the booths. So I mentioned bringing the best of breed technologies to bear. So one of the things we've done is we've partnered with Mellanox. So Mellanox has been the leader in the low latency, high bandwidth interface interconnect with their Connect IB technology. And so we have systems which you can see with Xgene 64-bit microprocessor with the Connect IB. And this is with code that's just been ported over, and it just works. And the latency that we're seeing is about a 1.5 microsecond, and we see close to 40 gigabits per second of sustained throughput. Now, this is without any optimizations. So we expect the bandwidth to go up and the latencies to come down below 1 microsecond. Second, we have systems which our partners are developing with integrated GPU. You may have seen some of the announcements that have come out from NVIDIA on the wire. And this is with the Tesla K20 CPU. Now, one of the key things is when you look at the benchmark, one of the benchmarks, which is HPCG, which you may be familiar with, there is no difference in the performance of an x86 system with K20 versus an Xgene ARM64 system with K20. So that's a very good proof for us that ARM, the high performance of ARM and low energy efficiency can really make a difference. So I'll leave you with the last slide, which shows the system integrators and the OEMs that are working with us that have made announcements. And you can see the live demos of a lot of these systems at our booth 506. And you're also welcome to visit the booths of Eurotech, HP, E4, and SoftIron. And I'm really excited over here. And in the end, I'll just leave you with one thought. There is always room for innovation, and there's always room for competition, which is a healthy thing. And we're hoping that this is the start of something that will be useful. And I'm really proud and glad to be here in Europe, which I mean, we are in the United States, and we sort of see Europe as one of the leaders in terms of pushing the frontier of energy efficient computing with a lot of the initiatives like Edge 2020 and the others. So I'm really glad to be here and hope to be here again next time. Thank you.